need to determine the degree of homogeneity of this function using the Euler's theorem. And it's very, very simple to analyze once you understand the concept of Euler's theorem. Now, if we want to solve this problem, let's say we have a solution here. This is our solution. You should remember that Euler's theorem is given by a formula. This is Euler's theorem. Euler's theorem is given by, let's say you are having L and K here as the factors of production. So you're going to have L dq over dl plus K dq over dk equals n function of q. N function of q. Once you have done that, then you need to differentiate this function with respect to L and also differentiate with respect to K. Now the question is, how do I know that I need to differentiate with respect to L and K? It is because the major factors, the major variables in these functions are Q, L, and K, where A is an efficiency parameter. Just an efficiency parameter, so you don't need to, or we can also call it a technology. You don't need to look at that first. So we're going to have dq dl. Your dq dl equals alpha A L alpha K beta minus 1. You know, there's minus 1 there. And this function can also be written as A alpha A L alpha K beta divided by L. That is the first derivative with respect to L. We are still going to take a partial derivative of the same function with respect to K. And this is going to be beta A L alpha capital, which is K beta minus 1. And this can also be written as, let's write it here. Let's write it here. This can also be written as dq dl dk equals beta Al alpha K beta over K. Remember this formula. Now, this formula says L dq dl plus K dq dk equals n function of Q. On this, we are going to have our L times dq dl. Your dq dl is this. Our dq dl is alpha Al alpha K beta over L times plus K into brackets dq dk. The dq dk is this. Beta Al alpha K beta over K equals n, which represents your degree of homogeneity, function of Q. Function of Q. So, from here, our L can cancel L, and our K can cancel K. So we have alpha Al alpha K beta plus beta Al alpha K beta equals n function of Q. Good. So if you look at this critically, you see that something is common here. It's common. You have to factorize it out. Now what we're going to do is alpha plus beta Al alpha K beta equal to n times Q. You know, it's the same. So if you look at the question here, our Q equals Al alpha K beta. Since, you now say, since Q equals Al alpha K beta, we can assume that this is also Q. So we have our alpha plus beta into Q equals N times Q. Now, if you divide both sides by Q, you're going to have your N to be equal to alpha plus beta. Thus, these alpha plus beta represent the degree of homogeneity that you are required to find it. Remember,